You're given an array of n integers and another integer k. You need to find the longest subarray having their sum less than or equal to k. Let's take this array. Subarray of an array is any contiguous block of elements from that array. So for our given subarray, this is a subarray, this is a subarray, and this is also a subarray. Our task is to find the longest subarray having their sum less than or equal to k. Let's say our k is 18. So we take a subarray like this, add the elements, and we get 17. This subarray has length 3, so that's a possible answer. Let's take the subarray 7195. Add the elements and we get 22. That's greater than k. Let's take the subarray 1953. Add the elements and we get 18. The length of this subarray is 4, but we still need to check if any of the other subarrays having length longer than 4 is having a sum that is less than or equal to 18. So how do we simulate this in code? We could try and identify all the subarrays in our code and return the longest of those subarrays that sum to the value less than or equal to k. But trying out all the subarrays is a time-consuming process, so definitely not efficient. This is a good point to understand that we only need to consider subarrays having sum less than equal to k. Let's use that intuition to develop a better strategy. For solving this, we could use a technique called the sliding window technique. First, we'll define a window of size 0. A window has a left extreme and a right extreme. We'll use variables left and right. Initially, values of left and right are 0. We'll keep track of the maximum length that we find in an integer variable maxLen. We'll initially set it to -1 just in case we never find a subarray of sum less than or equal to k. We need to keep moving the right side of the window as long as the sum of the current window is less than or equal to k. At some point, the sum becomes greater than k. Now, we need to shrink the window by moving the left side of the window to the right, and keep track of the sum by negating the elements we skipped. We do this while the sum of the window is still greater than k. Once this part is done, we just need to check if the current window size is greater than the maxLen and update maxLen if it is. Sliding windows can be a bit tricky to implement. I would suggest to try as many sliding window problems as possible. If you're familiar with LeetCode, you can go to the problems page and select the sliding window tag. And it will give you a bunch of problems that can be solved using some sort of variant of sliding window technique. I hope you enjoyed this video. If you did, let me know in the comments and please consider subscribing. See you soon.